Hi, hello everyone. Welcome back to our channel Samarth Official. In this video, you'll learn about how to find stress and deformation on a thin elastic steel plate with central hole by considering axisymmetric model of the same. The previous video, the same problem was solved by taking the complete model, and you can observe the difference in solving the same problem by using complete model and also the axisymmetric model. Here I am using the same model which was modeled by using ANSYS design modeler, the modeling of which was shown in the previous video. Okay, you can see this. This is the complete model, axisymmetric model. This is axisymmetric about y-axis and axisymmetric about x-axis. Here in this problem, we'll take the 1/4 of this model, means which is nothing but axisymmetric model will take in order to reduce the computational time of solving this problem. Open ANSYS workbench. I have opened the previously solved problem. From this, I'll take the geometry. I'll copy the geometry or duplicate the geometry. Uh, just click on this down arrow and click on duplicate. So this will give you the copy of this geometry which is already created. Double click on this and you can rename this as plate with hole axisymmetric model. Okay, select this geometry, right click, edit geometry in design modeler. So this will take you to design modeler workbench. Okay, right click on look at. So now go to tools, click on symmetry. So for the symmetry, you need to select the plane of symmetry, as this is three-dimensional model you have created with thickness of 10 mm. So plane of symmetry here is, you can see ZX plane. So I'll select the ZX plane. Okay, and click on generate. So it is cut about the plane of symmetry. So again, this is symmetric about this axis or this plane, as it is three-dimensional. This is symmetric about YZ plane. So now again, you just go to tools, again add the symmetry. Okay. Now select this ZY plane. Okay, and click on apply and click on generate. So this is the symmetric, means 1/4 of this whole part. Okay, whole model. This is the symmetric model. We need to analyze this symmetric model now. This will reduce your computational time. So just right click, zoom to fit, so you can see the symmetric model. Okay, file, close design modeler. So now I need to do a static structural. So you just check static structural in analysis systems. So where is static structural? Okay, so you can drag this and place it here. So the geometry is shared with static structural analysis. So now I can go to this model, click on this model, right click, edit. So this will open the geometry model for the meshing and giving constraints. Okay. This is the axisymmetric model. So you need to check the material. Material is taken as structural steel. If you want to edit, you can edit this. You can change the material also. We'll see in the next videos, and we'll see here. Uh, so this is the mesh. Just select this mesh, right click, generate mesh. So this has generated the mesh. Again, select the mesh, right click, insert, sizing. I want to change the size of this mesh. Okay, so I'll give size of meshes 10 mm. Press enter. And for this, you need to select the geometry. For selecting geometry, you just ensure that body is selected here and select this body. Click on apply. Okay. Now select the mesh, right click, update. So you can see the mesh sizes. Okay. So you can see all these are in tick marks. All these are okay. And this is in question mark, like static structural. So now you need to give the constraint, select this, right click, insert. Okay. For the symmetric problems, you need to select the frictionless support. Okay. Just click on the center mouse button and scroll this. Like you can move this such that the body will be rotated, and select this face. Again, move this body, press Control, select this face, and again press Control, select this face. Okay. So as the thickness is very less compared to length and width, so they have taken symmetric face as this end face. There won't be much change in result. Okay. Click on apply. So now we need to apply the force. Select static structural, right click, insert, force. Select this face. Ensure before selecting face, this is in face. So select this face and click on apply, and the value of the force will be components, and you can see this force must be applied in x direction. Right click, zoom to fit. So x component of force, normally the force acting on this is 100 kilonewtons. So as this is axisymmetric, means you have made this component half. So you will take the half of this total load. Okay. So half of the total load is 550 kilonewtons. 50 into 10 cube. Okay. This applied. So the force is applied and frictionless support is applied. So now you need to solve this. Select this, right click, solve. Okay. So insert, right click. So it is just solving. So this is ready. You can see the tick marks here, green tick marks here. The solution is solved, but in order to view the solution, you need to do the post-processing things. Okay. So select the solution, right click, insert. So I need stress value, normal stress. Click on normal stress. And solution, right click, insert any deformation, directional deformation. So I need x component of deformation. So you can see orientation x axis. Select this, right click, evaluate all results. Right click, view, print. Okay. Click on this normal stress. So you can see the normal stress. This is maximum value and this is the minimum value. Maximum value occurs here and minimum value like will be occurring here. So just click on animation. This is how stress variation occurs while loading. Select this directional deformation. So this is the maximum deflection in x direction and this is the minimum deflection in x direction. So you can see this red part, this is the maximum deflection in x direction. On play, so you can see the animation of deflection in x direction. Okay, thank you.